Okay, let us now complete this print list and find function for the circular linked list. The print list function is going to print the content of each node of the circular linked list starting from the first node up to the last node. Now we need to take care of one thing here while traversing the circular linked list. We do not have a null there at the next pointer field of the last node. So we need to take care of how to stop the loop when we traverse the entire linked list. So for that purpose, we'll be taking an integer variable, a flag, and we assign 0 to that done, and we'll actually iterate as long as the done is not 1. So this will be the thing that will be applying here. So if we just print it, if we print the content of the last node, then we'll just turn on done. So we'll see how that works. So let me take one node pointer current, and we assign the address of the first node from where we are starting the traversal, and we can get the address of the first node from lstptr arrow tail arrow next. That's the address of the first node. So now when we enter into this while loop, for the first time we'll print the content of the current node, that is the current arrow data. So we can just do that, current arrow data here, and that will print the content of the current node. Now immediately after printing the content of the current node, we'll check if we have printed the content of the last node. So we'll check the pointer if the current pointer is equals with the tail. So if that is equals with the tail, that means we have just printed the content of the last node. So we can just turn on done in that case, because we are done printing everything there, and that will terminate the loop. Otherwise we'll just move to the next node. So current equals current arrow next, and okay, that's it. Now it's going to print the content of each node starting from the first node until it reaches the last node. Now let me just write the find operation. It's going to be similar actually. We need to traverse the linked list in the same way as we did in case of print. So we'll take, I can just copy the code from there. We'll need the same loop. Instead of printing, we'll compare if content of the current node equals with the target. So the things are going to be same. So instead of printing here, we'll check if current arrow data that equals with the target that we passed to this. Now if that happens to be equal, then we can just return the address of this current node because we found the target. Otherwise we'll check if we have just compared the content of the last node. If we have compared the content of the last node and we are here, that means the target is not there in the entire linked list. So we can just turn on done to 1, and then otherwise if there are nodes left, we can just move to the next node for checking. At the end we are returning null. If we are coming out of the while loop, then we have searched the entire linked list. We have not found the target there, so we are returning null in that case. So that's how the find works. So we'll call these operations from the main function. I have written all these calls there from the main. I'll show you that. Here is the updated menu. You can see all these circular linked list operations are enlisted there, and I have declared the circular linked list object here in the main, and I have passed that to the init list, the address of that object to the init list for the initialization. These things are just same exactly as we did in case of single linked list and double linked list, and these are not part of the data structure. Actually, the main part that you need to concentrate on is the logic of adding a new node in the linked list and deleting the node from the linked list or from the circular linked list. Those things are important, and those things will help you to realize the conception of linked list. These things are just for the testing whether our code is working fine or not. So here is the calling. Under the switch case, we are just calling all these functions, and these things are just same as we did in case of the previous programs. So I'll just go ahead and compile and run this program, and we'll show you how that works. So let's move on. Okay, let me compile that file, linkedlist.c. You can change the name to circularlist.c if you wish. I kept the same name. It has been compiled successfully. Let me run that. Here is the menu. So I'll create the linked list with some 5 different integer values randomly, and let me choose option 4. So here is the content of each of these nodes there in the circular linked list. 620 is the content of the first node and 374 is the content of the last node. Now if I choose option 4, I'm sorry, let me choose option 2 to insert a new node, say 900. Okay, now let me see that. You can see 900 has been added at the end of the circular linked list. I can go ahead and add one more node. So it will be option 2. Okay, 950. And you can see that 950 has been added to the rear. And let's go ahead and delete some nodes. Option 3. So it has been deleted. I mean, the first node has been deleted, 620. Now again, if I call that option 3, it will delete the current first node, that is 95. So it is working fine. You can use the find as well. Let me choose find, and I'll try to find, say, 374. And you can see that target node exists and it is printing the address of that target node. And that's how the circular linked list can be built. And we can use all these insert and delete operations for building the circular queue. As you can see that if we have only that insert and delete operation, then we are actually having the circular queue, because insert is going to add the new node at the end of the linked list and delete is going to delete it from the front of the linked list. So obviously we're going to get first in first out order. So that's it. I mean, we came to the end of this. Thank you very much for watching.